Good morning, students. We're going to cover sections 1.8 and sections 1.9. Combinations of functions, composite functions, and inverses. Okay, so if you have any questions, it's going to be not a quick lesson, but a good lesson. So we're actually going to come back to these definitions. I'll fill them in as we go to them in the book. So arithmetic combinations are actually going to be easier to see than just to write. But basically, it's going to be either a sum, difference, product, or quotient. Now, could it be a combination of those? Yes. So this is two or more functions. In this case, it will be two functions, but yeah. So let's look at these. So the sum, pretty simple. It's when we have two functions, f plus g of x, so it's easier when they're the same. And this is basically f of x plus g of x, okay? So it's really not too complex there. So I'll just write these down. So we have the sum would be f of x plus g of x. So you just add them together. Okay, so the difference is going to be pretty simple. It's going to be f of x minus g of x. Okay? Well, and I'll write it in here. So it's f minus g. Sorry. So it's f minus g of x equals f of x minus g of x. Okay? Now the product is going to be pretty simple. So it's going to be simple. It's just going to be f of x times g of x, okay? Okay, so this will look like this, g of x equals f of x g of x, okay? Now the reason why we use this dot right here is because there's a different formula for what we're going to do later with composites. Okay, quotient is easy. So this is going to be f of x over g of x, where g of x does not equal 0. Okay, you can't have g of x equal 0, so this is going to be, in parentheses, f divided by g of x equals f of x divided by g of x, where g of x is not, yeah, how to do that? Oh, let's show it here. Not equal. Oh, it's n cube. Okay, not equal to 0. Okay, let's look at some examples. So we'll go through this quickly. F of x plus and g of x, where we're going to add them, subtract, multiply, and divide. So I'm actually going to go through this quick if you need to do it. So the sum is going to be x squared plus 4x. Difference is going to be negative x squared plus 2. The product, I might actually, so this is just solutions, okay? If you want to do the math with them, you're free to, but this is the answers. So multiplication, so we get 2x cubed plus 5x squared plus, sorry, not plus, okay, minus 1. Okay, and the quotient quotient is going to be 2x plus 1 over x squared plus 2x minus 1, where, x squared plus 2x minus 1 equals 0. So x plus 1, it's my, sorry. Actually, does this have any? I don't think this does. Yeah, this doesn't. Okay. So it has no, but you could just do it this way. Okay. Cannot equal 0. Okay. This is does not equal. Okay. So that's the quotient, that's the product, difference, and sum. Do you have any questions over that? That's a great one to ask. Okay, I'm gonna move on. There's practice combinations in 1.8, which we'll go over in class. So I will ask you questions about them. So if you want to be ahead, these are great ones to practice. Okay. Okay. Now we're going to go into composition, which is actually up here. So composition, the composition of the function f with the function g is f of g, this is f of g, where you substitute g of x in for Rx, okay? And the domain of f of g is the set of all x in the function f, in the function g, such that g of x is in the domain of f. So essentially, this is what this is saying. So the domain of the composition is all the x values that are also going to be in g of x that produce x values that are also in f of x. So essentially, if it doesn't work in g of x and it doesn't work in f of x, then it's not going to be in the functions. Okay, let's look at some composition. Okay, let's make some compositions. F of g of x. So we have our f of x. F of x equals x plus 2. G of x equals 4 minus x squared. So f of g, I always used to think this was fog when I was growing up, is this. So we plug in 4 minus x squared in for this x plus 2. So this becomes 6 minus x squared. Okay, what about g of f? So g of f, we plug in x plus 2 in for x right here. In for x right here. And we get 4 minus x squared minus 4x minus 4. If you solve this out, we get negative x squared minus 4x. Okay, and then what if we plug in a negative 2? So you actually just plug in the negative 2 here. So g of f negative 2, we get negative 2 squared minus 4 negative 2. We get negative, this is 4, negative 4 plus 8 equals negative 4. Answer is negative 4. Is that correct? Well, actually it should be positive 4, not negative 4, but there we go. That's correct. Okay, that's example 5. There are more practice problems we will do as a class. So if you have any questions on that, if there is this example 6, which which is a great question to practice because perhaps we will cover it in class. So if you want to do that, go ahead. It is in the book, so the answer is right there. It is pretty clear how to find this. So domain, remember, you kind of have to look at what limits this domain right here. Okay, this domain, this doesn't have a limit. F doesn't, but G does. So what doesn't work for X? That's going to affect our domain. Okay? So what doesn't work for X? And actually, I really put this. So X is going to be what you could do is do the interval. So the interval is better. So it's going to close, meaning it can equal this. It can equal -3 or +3. Okay, so that is actually going to be our interval. And if you look in the book, you can either do it graphically or with decimals. Okay? Okay, bye guys.